This video showcases the Driver Alcohol Detection System for Safety, also known as DADS, and the Driven to Protect initiative, which develops and tests advanced technology to prevent alcohol-related crashes, injuries, and fatalities throughout the Commonwealth. Here you'll see some of the laboratory tests that the prototype breath sensor goes through before being released for real-world, on-road testing. One part of the DADS program is working to develop passive breath alcohol sensors that can be installed in cars to let a driver know when they are above the legal blood alcohol concentration limit and should not drive. Before the current generation of sensors can be installed in vehicles, the DADS lab at KEA Technologies thoroughly test each of the sensors to ensure they function accurately. When the sensors reach the lab, the first step is to visually inspect them to determine whether there is any shipping damage that could cause the sensor to not work properly. Next, the lab checks to make sure the sensor turns on and can connect to the operating software, which is used to further test the sensors. This basic test helps to quickly identify damaged or malfunctioning sensors prior to testing. Using vendor-provided operating software, the lab tests whether the sensor can receive a naturally exhaled human breath and whether it can detect alcohol in that breath. In order to simulate alcohol, the test engineer blows across a pad soaked in ethanol to roughly simulate alcohol in a breath. The breath sensor works by detecting the amount of carbon dioxide or CO2 and ethyl alcohol in a driver's breath. A standard human breath has a known amount of CO2. By comparing the ratio of CO2 molecules to alcohol molecules, the sensor can then determine a person's breath alcohol content, and subsequently, whether they are within the legal limit to drive. Temperature is one concern in the testing process because these sensors must function perfectly in cars located anywhere from Alaska to Death Valley. The lab tests every sensor at the temperature extremes typically experienced by a motor vehicle. The sensor is baked at plus 185 degrees Fahrenheit and frozen at minus 40 degrees Fahrenheit to ensure extreme weather will not impede its proper functioning. One of the most important steps in testing is to ensure that the sensors can detect the amount of alcohol in a driver's breath accurately. The lab tests simulate a human breath using 3 different gas mixtures, each with a different ratio of alcohol to CO2, similar to the different levels of breath alcohol content that humans would present. The simulated breath that is used for testing is made right in the DADS lab. The lab precisely and accurately combines oxygen, carbon dioxide, nitrogen, and ethanol to make the test gas, thereby simulating a human breath with a known alcohol content. This breath is delivered by a machine invented in the DADS lab, which is affectionately named Frankenstein because it can breathe 15 breaths per minute, which is the average number of breaths per minute for all of us. The last step for this particular generation of sensors is to give them some bling, a copper casing. Copper blocks electromagnetic interference emitted from your phone, cell or radio signal towers, or even the vehicle's own onboard computer and electronic systems. This allows the lab to investigate whether electromagnetic interference affects the sensors by comparing data from previous generations of unprotected sensors to the new copper-wrapped ones. All of this data is used to improve the performance algorithms in the existing generation of sensors while providing knowledge to improve future generations of sensors. Here is a sensor ready to be installed into a vehicle. The reason the DADS project is working so hard to get these sensors ready to be installed into vehicles is that these sensors have the potential to save thousands of lives each year. Did you know that in Virginia, your chance of being in an alcohol-related crash during your lifetime is 1 in 6? This costs the Commonwealth $429 million every year. In the U.S., an average of 28 people die every day in alcohol-related crashes. This doesn't account for the many thousands of friends and family impacted by the tragic, but preventable, injury or loss of their loved ones. The DADS sensors have the potential to let a driver know when they are too intoxicated to drive and prevent them from getting on the road. If everyone had these sensors, an estimated 34% of all traffic fatalities could be avoided. Learn more about this life-saving technology at dads.org.